There was a time when the Earth was silent, a world of stone, ocean, and sky, waiting for something to stir. Then, around 541 million years ago, that silence broke. Life found rhythm, color, and motion. The Paleozoic Era had begun, an age of oceans filled with strange creatures, forests that shaped the air and continents that collided to build the bones of our planet. It was here in this age of beginnings that the Earth learned to live, to adapt, and to dream. Welcome to Chronicles of Earth, where we travel through deep time, not as distant observers, but as witnesses of the forces that made us who we are. This is not just history, it's the memory of the planet itself, written in fire, stone, and breath. Through the story of the Paleozoic, we'll walk where trilobites once crawled, stand beneath forests older than mountains, and watch as continents join and fracture in a slow, cosmic heartbeat. In this episode, we uncover how life transformed from simple to complex, how the first forests gave birth to the oxygen we now breathe, and how cataclysms nearly erased everything, only for existence to rise again, stronger and wiser. From the Cambrian seas to the great dying of the Permian, we'll follow the pulse of the planet through its triumphs and tragedies, understanding not only how it changed, but why it endured. Because to tell the story of the Paleozoic is to tell the story of survival, of how Earth, against impossible odds, learned to begin again. Every breath we take, every mountain we climb, every shadow that falls across the land carries the memory of that era. The continents beneath our feet are not just ground, they are time itself, folded and waiting to be remembered. So take a deep breath and look at the world around you. The air that fills your lungs was once the breath of ancient ferns. The rock beneath your feet was once the floor of a vanished sea. And the story you about to hear, the story of the Paleozoic, is your story too. This is Chronicles of Earth, where the past breathes and the planet remembers. The dawn of complex life. The Earth stood at the edge of transformation. For billions of years, oceans had whispered to the wind, waiting for something extraordinary to happen. And then, in a geological blink, life found rhythm, complexity, and form. This was the dawn of the Paleozoic Era, when the quiet blue planet became a world of movement, color, and struggle. The silence of the Precambrian ended, replaced by the pulse of life that would forever alter the history of the Earth. Beneath shallow seas, microbial mats gave way to thriving ecosystems. Multicellular life evolved into astonishing diversity, soft-bodied creatures, armored trilobites, and the first complex organisms that would shape the course of biological evolution. The oceans became laboratories of experimentation, where survival meant constant adaptation to an ever-changing planet. Here, in these ancient waters, life learned the first lesson of existence. Nothing endures without change. The continents themselves were restless. The great landmasses scattered across the globe began to drift slowly, colliding and separating in a perpetual dance of creation and destruction. Mountain ranges rose like the spines of the planet, while volcanic eruptions poured minerals into the seas, fueling the chemistry of life. The Earth was alive, not just biologically, but geologically, a planet sculpting itself through fire and time. In the Cambrian period, the Cambrian Explosion marked a revolution in the story of life. Over a few million years, nearly every major animal group appeared, an evolutionary storm that would define the architecture of the living world. Creatures like Anomalocaris hunted with alien precision, while trilobites ruled the ocean floor, leaving behind fossils that still whisper their story through stone. The origin of life had evolved into something far grander, the beginning of ecosystems. As photosynthesis spread, oxygen filled the seas and atmosphere, altering the planet's chemistry forever. For the first time, the blue skies we know began to take shape. This surge of oxygen allowed for more energy, more movement, more possibility. It was the era when life not only survived, but began to dream, a dream of eyes, fins, shells, and ultimately, consciousness. Geological forces shaped the destiny of life as well. Supervolcanoes reshaped coastlines, glaciations tested survival, and tectonic movements forged new environments. Each shift in the crust forced species to adapt or vanish. a silent law written in stone. The Earth was not gentle, but it was fertile in its chaos, and from this chaos, patterns of resilience emerged. The Paleozoic world was a tapestry of extremes: floods and droughts, warmth and ice, expansion and extinction. It was here that life proved its tenacity, crawling out of the sea, learning to breathe air, and exploring the unknown lands. Each era within the Paleozoic, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian, added a new verse to the song of existence, each one louder, more complex, and more fragile than the last. As the first vertebrates appeared and plants began to green the continents, the Earth transformed once again. The air shimmered with new possibilities. Rivers carved their way across barren rock. The story of the Paleozoic was no longer just about oceans. It was about expansion, conquest, and the courage of life to step beyond the water's edge. Humanity's distant ancestors began their first crawl into the sunlight, unaware that one day their descendants would look back and name this age the dawn of complex life. The Cambrian Explosion. Life finds its form. It began as a whisper in the depths of the ancient sea, an evolutionary spark that became a wildfire of creation. In the Cambrian period, roughly 541 million years ago, life reinvented itself. For the first time, the oceans teemed with creatures of unimaginable complexity and variety. The world's biology shifted from simplicity to symphony as Earth entered one of the most dramatic chapters in the history of the Earth, the Cambrian Explosion. Microscopic cells, once drifting aimlessly, learned to cooperate, specialize, and organize into forms that could move, sense, and defend. Nature became an artist sculpting with DNA, experimenting with eyes, shells, claws, and symmetry. This was not gradual evolution. It was a geological heartbeat that reshaped the destiny of life forever. Each new creature was a bold experiment in survival, each extinction a lesson written in the sands of ancient seas. Among these new pioneers were the trilobites, creatures with exoskeletons of chitin and compound eyes that saw the world through countless lenses. They became icons of this era, thriving in almost every environment. Nearby, the terrifying Anomalocaris prowled the waters, a predator unlike anything that had come before, swift, efficient, and utterly alien. The Cambrian Ocean was a living battlefield where innovation was the only weapon that mattered. The appearance of hard shells changed everything. For the first time, life left behind a permanent fossil record, a language of stone that modern science would one day learn to read. This mineral armor allowed creatures to survive predation, but it also reshaped the planet's chemistry. As calcium carbonate filled the seas, the delicate balance of minerals and gases evolved with it, tying geology and biology in an eternal bond. The ocean floor became a mosaic of color and motion. Sponges filtered the waters, worms burrowed into sediments, and strange beings with frilled bodies drifted like banners of light. Evolution favored those who could adapt to the shifting tides, and the competition drove rapid diversification. The Cambrian was nature's greatest experiment, a period when almost every major body plan found in modern animals made its debut. Yet, this explosion of life also brought the first glimpses of death on a planetary scale. For every species that thrived, countless others vanished without a trace. The selective power of nature became clear. Progress demanded sacrifice. In the fossil beds of places like the Burgess Shale, we find not only the triumphs of evolution, but its casualties, organisms that walked evolutionary dead ends, their beauty preserved only in stone. The Cambrian world was alien to us. Oxygen levels fluctuated, continents floated in unfamiliar configurations, and the moon hung closer, its tides more violent. Still, from this turbulence emerged the blueprint of future life, the foundation upon which all complexity would rise. The Cambrian did not just create species, it created the very idea of adaptation itself, a principle that would echo through every era to come. By the end of this period, the oceans had become a realm of hierarchy and power. Predators, prey, scavengers, and builders, all roles born from this crucible of change. The Cambrian Explosion was the universe discovering its own creativity through the medium of life. From the depths of an ancient ocean, the cosmos had found a new way to express itself, through beings that could move, feel, and eventually understand. The Ordovician Seas, Expansion and Extinction. As the Cambrian curtain closed, the Earth entered the Ordovician, an age of quiet grandeur and profound transformation. Life, once confined to shallow coasts, now surged into deeper waters, filling every niche the planet could offer. Coral reefs began to rise like living cathedrals, and the oceans shimmered with strange and elegant creatures. The history of the Earth had turned a new page, and the Ordovician world was a symphony of expansion. The continents drifted across the globe like rafts on molten seas. Laurentia, Gondwana, Baltica, names we've given to these ancient lands, floated under skies heavy with carbon dioxide. The climate was warm, the seas rich in nutrients, and evolution flourished. Marine life diversified into forms both delicate and fierce. Cephalopods with coiled shells patrolled the depths. Early fish-like creatures with armored heads explored the unknown, and plankton filled the sunlit waters, sustaining an explosion of life. Beneath the waves, reefs grew into sprawling fortresses, built by early corals and sponges. These structures became the heartbeat of the Ordovician seas, ecosystems of harmony and tension. Crinoids waved their feathery arms to catch drifting food, while trilobites crawled across the sea floor like restless wanderers. Every movement, every adaptation, was another note in nature's relentless song of survival. The planet was alive in ways it had never been before. But balance is delicate. The same oceans that nurtured abundance also hid the seeds of disaster. As volcanic activity reshaped the continents, the chemistry of the oceans shifted. Massive amounts of carbon were drawn out of the atmosphere, cooling the planet. Ice began to form at the poles quietly, almost imperceptibly, until glaciers grew so vast they began to rewrite the geography of Earth itself. A new kind of extinction was coming, one born not of fire, but of cold. The Ordovician glaciation was merciless. Sea levels dropped as ice locked away water, exposing coral reefs and shallow habitats to desolation. Species adapted to warmth perished, their once vibrant ecosystems turning silent. The first great extinction in Earth's history began. More than 80% of marine life vanished, a staggering loss that reshaped the evolutionary path forever. Yet from this devastation, life would rise again, stronger and wiser. The survivors were the architects of the future. Simple fish with jaws in their infancy, mollusks that could endure change, and plankton that adapted to shifting chemistry. These were the silent victors. Evolution had been tested, and the Earth had learned something vital: that survival depended not on strength but on flexibility. The cycle of creation and destruction, of expansion and collapse, had become part of the planet's rhythm. In the ruins of the Ordovician seas, life retreated, regrouped, and prepared for another chapter. The oceans still glimmered with fragments of beauty, drifting spores, floating debris, and the faint pulse of those who endured. The story of the Earth was not a straight line but a spiral, each extinction carving room for new beginnings. The universe, through the language of geology, had whispered another truth: even in loss, there is potential. By the time the ice began to melt and the seas rose again, a new balance emerged. The survivors carried the legacy of the Ordovician into the next era, one of renewal and exploration. Ahead lay the Silurian period, when life would attempt something it had never done before: to conquer the land. The Silurian awakening. Life steps onto land. When the ice of the Ordovician finally receded, the Earth breathed again. Oceans swelled, temperatures climbed, and the scars of extinction began to heal beneath a gentler sun. It was the Silurian period, a time when resilience blossomed into innovation. The planet, tempered by catastrophe, began to write a new chapter in the history of the Earth, the awakening of life beyond the sea. The reefs returned, stronger and more elaborate than before, built by corals and sponges that had survived the long winter of extinction. New species flourished in the warming waters. Fish with primitive jaws, agile and alert, began to rule the shallows. The seas shimmered with schools of early vertebrates, testing speed, strength, and perception. The balance between predator and prey evolved into a new sophistication. Evolution had sharpened its tools. But it was not in the water where the greatest transformation unfolded. It was on the shores. The once barren coastlines, long sculpted by tides, began to host the first pioneers of land life. Tiny green plants crept across moist surfaces, their fragile forms gripping stone with primitive roots. They were simple, moss-like, low to the ground, but they represented a revolutionary act. For the first time, life dared to face the open air. The atmosphere itself was changing, enriched by oxygen from photosynthetic organisms. Each breath of wind carried the promise of new possibilities. As plants spread, they transformed the climate, stabilizing soils and moderating temperatures. The land, once a realm of silence and dust, now began to pulse with the rhythm of photosynthesis, a heartbeat that would echo through every future forest and field. Soon arthropods followed. Scorpions, millipedes, and tiny insects ventured beyond the sea, their hard exoskeletons protecting them from the unfamiliar dryness. They explored tidal flats and damp environments, feeding on decaying organic matter left by early plants. These creatures became the first true colonizers of land, explorers in a world still alien, where every step was a gamble and every breath an experiment in survival. The Silurian atmosphere glowed with warmth, the continents gathering moisture, and rivers carving through untouched landscapes. The planet had entered a balance between sea and soil, between ancient oceans and the promise of forests yet to come. It was an age of quiet progress, where the small and the humble laid the foundations for giants. Beneath the surface, tectonic movements continued their eternal work. Continents drifted closer, oceans narrowed, and mountains rose like watchtowers above the horizon. The union of these shifting plates would one day form vast supercontinents, but for now their dance nurtured diversity, creating islands, shallow seas, and countless habitats that would fuel evolution's next surge. The Silurian world was serene, yet charged with anticipation. Life had proven its ability to adapt to extremes, ice, fire, and now the air itself. With roots anchoring the land and creatures crawling upon it, the boundaries of possibility expanded forever. The earth had taken its first breath of green, and nothing would ever be the same again. Ahead lay the Devonian, the age when life would explode once more, reaching for mastery over the continents themselves. The Devonian, the age of fishes and the rise of forests. The Silurian had opened the door, but it was the Devonian that stepped through it with boldness and grandeur. Known as the Age of Fishes, this era, stretching from roughly 419 to 359 million years ago, was when the planet seas became theaters of evolution and its continents began to wear a mantle of green. It was a time when the Earth itself seemed to breathe deeper, richer, and more alive than ever before in the history of the Earth. Beneath shimmering blue waters, life reached new levels of complexity and design. The oceans filled with armored placoderms, prehistoric giants like Dunkleosteus, their jaws capable of crushing bone and shell alike. Streamlined sharks patrolled the depths, while lobe-finned fish, with their muscular fins and primitive lungs, explored shallow lagoons. Every ripple carried the echoes of change, for within these fish lay the blueprint for the first vertebrates to walk on land. Along the coasts, plants reached higher toward the sun. What began as mossy carpets during the Silurian became vast green landscapes during the Devonian. The first true trees appeared, towering Archaeopteris forests that shaded rivers and anchored soils with deep roots. Their leaves exhaled oxygen, transforming the planet's atmosphere. The color of life spread across the continents, and for the first time the Earth looked familiar, a world of blue seas and green lands. This transformation altered everything. Rivers meandered through lush valleys, depositing sediments that would one day become stone. Rain carved intricate channels, creating fertile deltas teeming with amphibious creatures. On land, early arthropods evolved into hunters and scavengers, forming miniature ecosystems that foreshadowed the complexity of modern life. The planet was alive in every direction, above, below, and within. But evolution is never gentle. The same forces that nurtured abundance also shaped extinction. Volcanic eruptions altered climates, while shifts in ocean chemistry brought deadly anoxia, the depletion of oxygen that suffocated marine life. Entire reefs collapsed, and once dominant species vanished. The Devonian extinctions, though slower than others, were profound, clearing the stage for new players in the grand story of evolution. Among the survivors were the tetrapods, the first vertebrates to venture fully onto land. From lobe-finned fish like Tiktaalik came limbs, lungs, and the courage to explore beyond the tides. These ancient pioneers dragged themselves from the shallows, their fins transforming into crude legs, their gills complemented by air-breathing organs. In their struggle, we find the earliest roots of every land animal that would ever exist, including humanity itself. As forests expanded, they changed the chemistry of the world. Oxygen levels soared, while carbon dioxide declined, cooling the climate. The Earth entered a delicate dance between life and atmosphere, one that continues to this day. The first soils formed, rivers deepened, and rainfall patterns began to mirror those of our modern planet. Life had become an engineer, reshaping not just ecosystems but the very face of the Earth. By the end of the Devonian, the stage was set for new dramas, creatures learning to crawl, breathe, and hunt beneath canopies of green. The oceans remained powerful, but the land was no longer silent. The great experiment of life had found a new frontier, and the whispers of the Devonian carried a single quiet promise: the world belongs to those who adapt. Next came the Carboniferous, where the planet itself would bloom into forests of giants and skies rich with oxygen, preparing the stage for creatures both marvelous and monstrous. The Carboniferous forest empires and the breath of giants. The Devonian had planted the seeds, but the Carboniferous turned them into empires. From 359 to 299 million years ago, the Earth transformed into a living cathedral of green, vast rainforests that stretched across the continents, their canopies lost in mist and thunder. It was a time when life breathed deeper, when the air itself grew rich with oxygen, and when the planet pulsed with vitality unlike anything before in the history of the Earth. Every horizon was covered in forests of towering lycophytes, ferns, and horsetails, plants that reached heights of 30 meters, their trunks coated in moss and moisture. Swamps spread like emerald oceans across the lowlands, filled with insects the size of birds and dragonflies, with wings wider than a human arm. Amphibians, descendants of the Devonian pioneers, now ruled these wet realms, their calls echoing through forests thick with steam and shadow. The Carboniferous world was lush, humid, and alive with movement. Beneath this paradise, an unseen process unfolded. The dense vegetation, falling and decaying in stagnant swamps, was buried beneath sediments, trapped for millions of years under pressure and heat. It was here that coal, the fossilized remains of ancient forests, began to form. Each black seam beneath our feet tells the story of a primeval Earth, where photosynthesis wrote its legacy in carbon and stone. The modern world, with its engines and electricity, still runs on the breath of those ancient trees. The high oxygen content shaped life in extraordinary ways. Insects grew to monstrous proportions, their bodies fueled by air rich enough to sustain enormous forms. Giant millipedes called Arthropleura stretched over 2 meters long, crawling across the forest floor like living relics of another reality. The atmosphere shimmered with humidity and lightning, storms rumbling across continents that were slowly merging into the supercontinent Pangaea. It was a world both fertile and foreboding, a paradise on the brink of transformation. The amphibians thrived, diversifying into forms adapted to both land and water, yet the forests, dense and unbroken, also hid danger. Predators evolved stealth and strength, while plants competed fiercely for sunlight and space. Evolution accelerated in silence, every adaptation countered by another, every success shadowed by vulnerability. The Carboniferous was an age of equilibrium where abundance itself became the test. But stability is an illusion. As the continents drifted and collided, climates began to shift. Rainforests fragmented, swamps dried, and ecosystems that had flourished for millions of years started to collapse. The great coal forests, those green lungs of the planet, withered under changing skies. Amphibians, once dominant, faced decline, giving way to creatures more suited to dryness and unpredictability. The reptiles. Reptiles were the new architects of survival. With shelled eggs that protected embryos from dehydration, they no longer depended on water for reproduction. This innovation marked a turning point. Life had fully conquered the land. Evolution had learned independence. The reptiles' thick skin and efficient lungs allowed them to thrive where amphibians faltered, heralding the rise of new dynasties that would one day rule the Earth. As the Carboniferous ended, oxygen levels began to fall, the climate cooled, and the lush jungles retreated. The world grew darker, harsher, and quieter, yet from the ashes of the green empires, life prepared for another transformation, one that would test its endurance more than ever before. The Permian period awaited, a time when continents united, deserts spread, and survival itself became the planet's most sacred law. The Permian, the great unification, and the edge of extinction. By the dawn of the Permian period, roughly 299 million years ago, the Earth had grown both magnificent and perilous. The scattered continents that once drifted freely had now joined in a colossal embrace, forming the supercontinent Pangaea, a single vast landmass surrounded by the endless Panthalassic Ocean. It was the grand unification of the planet's crust, a monumental chapter in the history of the Earth and the prelude to both triumph and catastrophe. Across this immense world, climates shifted to extremes. Deserts the size of continents stretched beneath unrelenting suns, while seasonal storms carved scars across the land. The interior of Pangaea was dry and harsh, far from the tempering influence of the oceans. The lush swamps of the Carboniferous had faded, replaced by arid plains dotted with hardy vegetation, conifers, cycads, and seed ferns, plants that had evolved to survive scarcity. Life had learned to adapt to the age of dust. Reptiles, the resilient heirs of the Carboniferous, now flourished. Freed from the need for water-bound reproduction, they spread across every corner of the land. Some grew enormous, armored like walking fortresses, while others became agile hunters, swift and cunning. Early synapsids, ancestors of mammals, began to dominate, their warm-blooded metabolisms allowing them to endure both heat and cold. Among them walked Dimetrodon, with its towering sail and predatory grace, a symbol of the new order of terrestrial life. In the seas, ammonites spiraled through the depths, while fish and marine reptiles adapted to the shifting chemistry of the oceans. Coral reefs returned, though fragile and shallow compared to their predecessors. Life's diversity reached astonishing levels, filling niches from mountain to abyss. It was a planet humming with energy, yet beneath this vitality, invisible tensions were building. The same geological forces that united the continents were also setting the stage for disaster. Volcanic eruptions began to stir in what is now Siberia, massive, relentless, and unimaginable in scale. For thousands of years, lava flooded the surface, releasing vast amounts of carbon dioxide and methane. The skies darkened with ash, the oceans grew acidic and temperatures soared. Rain became toxic, ecosystems collapsed, and food chains disintegrated. The Earth had turned against itself, its own heartbeat threatening to silence the life it had nurtured. The Permian Extinction, known as the Great Dying, was the most devastating event in Earth's history. Over 90% of marine species and 70% of land species vanished. Coral reefs disappeared for millions of years. Forests fell silent. Insects, once the masters of the Carboniferous skies, nearly went extinct. The air grew still, and even the oceans lost their oxygen, suffocating everything beneath their surface. It was the closest the planet had ever come to starting over. Yet, through the smoke and silence, a few survivors endured. Tiny burrowing reptiles, resilient plants, and microscopic organisms clung to life, hidden in pockets of stability. These fragile remnants carried the genetic memory of a world that had nearly ended. From them, the next great era would emerge, one that would see not only recovery but reinvention. The Triassic dawn was waiting, and with it, the rise of a new kind of life that would dominate the planet for the next 160 million years, the age of the dinosaurs. As the Permian faded into memory, the Earth stood scarred but alive, a testament to resilience written in fire and stone. From unification came destruction, and from destruction, the seed of renewal. The planet had survived its greatest trial, proving once more that even in ruin, life finds a way to begin again. The rebirth after the fire, the dawn of a new world. When the last echoes of the great dying faded, silence blanketed the planet. For millions of years, the Earth seemed suspended between death and rebirth. The land was scorched, the seas poisoned, the skies veiled in haze. Yet beneath this stillness, in the smallest and most resilient corners of creation, life began again. It was a fragile awakening, one that would redefine the history of the Earth and prove that renewal is woven into the planet's very nature. The Permian cataclysm had erased nearly everything, but extinction paradoxically clears the way for innovation. With ecosystems emptied, opportunity returned. In the early Triassic dawn, survivors emerged from their refuges, simple, unassuming creatures that would become the architects of a new world. Burrowing reptiles, hardy amphibians, and tiny shelled invertebrates reclaimed the barren landscapes. It was evolution's quiet restart, a world learning to breathe again after the storm. The climate remained harsh, unstable, and punishing. Vast deserts stretched across the heart of Pangaea, the air dry and heavy with heat. Rain was rare, vegetation sparse, and extinction still lingered like a shadow. But even here, photosynthesis resumed, painting faint streaks of green across the desolation. Rivers began to flow once more, carving life's return into the rock. The Earth, patient and persistent, was rebuilding itself molecule by molecule, species by species. In the seas, new life forms appeared where the old had vanished. Corals returned in modest forms, ammonites coiled through the recovering oceans, and new species of fish filled the empty ecological spaces. Plankton, small but mighty, multiplied, restoring the oxygen balance to the waters. The cycles of life, broken and bent, began to turn again. From ruin rose renewal, the same principle that would echo through every age to follow. On land, the first true archosaurs emerged, ancestors of crocodiles, pterosaurs, and the future rulers of Earth, the dinosaurs. These creatures were built for survival, efficient lungs, agile limbs, and an endurance unknown to their predecessors. They thrived where others faltered, spreading across continents still scarred by volcanic glass and dust. The seeds of a new dynasty had been planted in the ashes of extinction. Plants too staged their return. Hardy conifers and seed ferns took root in the thin soils, holding fast to the dry terrain. Over time, they would give rise to forests again, not the humid jungles of the Carboniferous, but hardier landscapes capable of withstanding drought and heat. The green returned slowly, cautiously, as if remembering the fire that had nearly ended it. Yet it did return, because life once awakened does not forget how to rise. This rebirth was not immediate, nor gentle. It took nearly 10 million years for biodiversity to recover, but when it did, the results were extraordinary. From scarcity came creativity, from chaos came balance. The survivors evolved into new forms, exploring untested evolutionary paths that would lead to astonishing future creatures, from massive predators to winged giants. The planet had been reforged through destruction, and in doing so, it had prepared itself for the next great act in its cosmic story. As the Triassic sun rose over a healing world, the Earth no longer resembled the one that came before. The silence of extinction had given way to the murmur of possibility. The air shimmered with promise, and the soil carried the weight of potential. The Paleozoic Era, the age of beginnings, had ended. Ahead lay the Mesozoic, when the planet would roar back to life with thunderous footsteps and wings that reached the clouds. The Earth once more was ready to dream. The legacy of the Paleozoic. Lessons written in stone. The Paleozoic era had come and gone, but its echoes still resonate through every mountain, ocean, and living cell. It was the Earth's first great symphony, a vast experiment where the planet learned to create, destroy, and rebuild itself. From the stillness of the Cambrian seas to the firestorms of the Permian's end, this era carved the foundation of everything that would follow. The story of the Paleozoic is not merely a chronicle of evolution, it is the record of resilience, the proof that life, once born, refuses to yield. Beneath our feet, the fossils of the Paleozoic whisper their testimony. Trilobites etched into limestone, fern imprints pressed into ancient coal, the bones of fish turned to stone, all remnants of worlds long vanished. Each layer of rock holds a memory of what once was, seas that surged where deserts now stand, forests buried beneath cities, and skies that once shimmered with higher oxygen than any creature breathes today. The geological record is not static, it is alive, telling the story of a planet that remembers. The continents we know, fractured and scattered, were once united under Pangaea, whose roots trace back to the restless drift of Paleozoic tectonics. The mountains that rise today, from the Appalachians to the Urals, are monuments of that time, formed when the planet folded its crust like origami. The Earth sculpted its identity then, a geophysical personality of motion, collision, and renewal. To study the Paleozoic is to watch the planet discovering its rhythm. It was also during this time that the blueprint for all complex life was written. From the first eukaryotic cells to the earliest fish and amphibians, every living creature today carries echoes of that ancient experiment. The structure of eyes, the rhythm of hearts, the code of DNA, all trace their lineage back to the silent revolutions of those primordial oceans. Humanity itself, though separated by hundreds of millions of years, walks on the bones of its Paleozoic ancestors. Yet the Paleozoic was more than progress. It was a lesson in impermanence. Every surge of abundance was followed by collapse. Every age of life ended in silence. The Earth teaches through contrast, reminding us that creation and destruction are partners in the same dance. The Cambrian Explosion and the Great Dying are not opposites, but reflections of the same truth. Balance demands both flourishing and loss. To exist on this planet is to live within that eternal cycle. Even today, the influence of the Paleozoic lingers. The coal we burn, the mountains we climb, the oil that fuels our civilization, all are relics of that ancient world. The industrial age is, in a sense, the resurrection of the Carboniferous, as humanity draws energy from forests that fell 300 million years ago. Our modern planet is powered by the ghosts of ferns and dragonflies, by sunlight trapped in the veins of forgotten swamps. The Paleozoic also left behind a question, one that still challenges science and philosophy alike. How does life endure through catastrophe? The answer lies not in dominance, but in adaptation. Species that survived did so by changing, by bending rather than breaking. It is a lesson written in stone and bone, a truth that transcends eras and species. The Earth's oldest wisdom is simple. Those who evolve endure. As we look back across the immense gulf of time, the Paleozoic reminds us of what it means to begin. It was an era of firsts, first shells, first forests, first steps on land, first breath of air. Every first that followed, from wings to thought, was made possible by what happened then. The Paleozoic was the planet's rehearsal for life as we know it, a prologue to all existence that came after. Its legacy endures not as fossils, but as the pulse that still beats in everything alive. The transition to the Mesozoic, a world reimagined by survival. When the Paleozoic ended, the Earth stood on the edge of silence, yet within that silence stirred possibility. The transition into the Mesozoic era, beginning around 252 million years ago, was not a clean divide but a long, uneven awakening. The planet had been humbled by destruction, reshaped by fire, and stripped of its abundance. But beneath the ashes of extinction, evolution was waiting, patient and deliberate, preparing to write the next magnificent chapter in the history of the Earth. The scars of the Great Dying lingered. Oceans were still acidic, skies hazy with volcanic residue, and continents barren from the collapse of ecosystems. For millions of years, the world was a place of emptiness, yet emptiness is the cradle of renewal. The first survivors, small and tenacious, began to explore this new reality. Their resilience became the seed from which the next age would bloom. From this fragile equilibrium, the story of recovery began to unfold. The Triassic dawn was a time of experimentation. The ecosystems that emerged were simpler, less crowded, but fiercely dynamic. Amphibians clung to rivers and swamps, while reptiles diversified across deserts and plains. The earliest dinosaurs appeared not as conquerors, but as survivors among survivors. Small, agile creatures built for efficiency in a demanding world. Alongside them, the first mammals scurried in the shadows, quiet and observant, carrying within them the promise of a distant future. The climate itself evolved alongside life. The earth warmed again, ice receded, and rainfall returned to the continents. Vegetation spread cautiously, conifers, cycads, and ginkgos anchoring the dry soils of Pangaea. Rivers and lakes became sanctuaries for recovery, while the atmosphere slowly regained its balance. The planet was healing, but it had changed forever. The cycles of extinction and rebirth had refined it, teaching it to sustain life through adversity. Geologically, the Earth was restless. The tectonic heartbeat that once united the continents began to pulse again. Pangaea, immense and dominant, started to fracture under internal pressure. Rifts opened, volcanoes blazed, and new coastlines formed. The supercontinent that had once symbolized unity now foreshadowed division. As Pangaea broke apart, it birthed the outlines of the modern world, the continents drifting toward the configurations we recognize today. Every evolutionary step in this transition carried the memory of what came before. The amphibians remembered the Devonian swamps. The reptiles remembered the deserts of the Permian. The plants remembered the rainforests of the Carboniferous. Nothing in nature is ever truly lost. It is transformed, recycled through time. The Triassic life forms were living echoes of the Paleozoic, carrying ancient lessons into a new geological age. This period also marked the rise of new ecological systems, predator-prey dynamics that favored intelligence, endurance, and adaptability. The Earth had become a testing ground for complexity, rewarding innovation over strength. The extinction that had once nearly erased life had also sharpened it, refining evolution into a more efficient architect. From this crucible of scarcity, the blueprints for the Mesozoic world and all its grandeurs were drawn. By the time the Triassic matured, the Earth had reinvented itself completely. The survivors of the Paleozoic had evolved into architects of empires, dinosaurs ready to dominate, reptiles poised to soar, and mammals prepared to endure in the shadows. The Earth was no longer fragile. It was bold, fertile, and ready to roar again. The Mesozoic dawn was not just a continuation, but a rebirth, proof that even after the greatest fall, the planet always rises again, reimagined by survival. The pale blue continuum, how the Paleozoic shapes us still. Though separated by hundreds of millions of years, the Paleozoic still breathes within us. Every heartbeat, every breath, every living forest carries the signature of that ancient age. It is not a distant relic. It is the foundation of the pale blue continuum that links the Earth's past to its present. To understand humanity's place in the cosmos, we must look back to when the planet first learned to evolve, to endure, and to create life that could think, move, and dream. The air we breathe today was first forged in the lungs of Paleozoic plants. The coal that fuels our cities was born from their fallen leaves, pressed under eons of silence. The calcium in our bones once drifted through Cambrian seas. We are, in every molecular sense, descendants of that age. The Paleozoic does not merely live in fossils, it lives in us, a chemical and biological inheritance written into the history of the Earth itself. Every layer of the crust beneath our feet carries a message from that time. The limestone that builds our cities is the remnant of ancient coral reefs. The mountains we climb are uplifted sediments of prehistoric oceans. Even the dust in the air, carried across continents by wind, is composed of particles that were once part of Paleozoic soils. The Earth recycles everything, matter, energy, and memory, in an eternal loop that ties us to those early worlds. The ecosystems we depend on still echo the structure born in that era. Predator and prey, plant and pollinator, cycle and decay, all are refinements of patterns first written in Paleozoic waters. The complexity of food webs, the delicate balance between carbon and oxygen, even the concept of ecological resilience. These were not inventions of modern life, but gifts from a planet that spent hundreds of millions of years learning through trial and extinction. The scientific study of this time has also reshaped our sense of wonder. Each fossil unearthed, each rock analyzed, pulls back the curtain of deep time, allowing us to see ourselves not as separate from nature, but as a continuation of it. The Paleozoic teaches humility, that intelligence, technology, and civilization are fleeting expressions of the same creative impulse that once sculpted trilobites and towering ferns. We are not above history. We are history made conscious. Even the cosmos seems to mirror this continuity. The cycles of birth, destruction, and renewal that define the Earth are the same that govern stars and galaxies. The death of a star once forged the elements that compose our planet, just as the death of an ecosystem gave rise to another. The Paleozoic, in its vastness, reflects this universal rhythm, the cosmic heartbeat manifesting through the soil and sea of a single world. Perhaps that is the most profound legacy of the Paleozoic. It reminds us that creation and extinction are not opposites, but collaborators. Every end contains the seed of a beginning. Every collapse, the potential for transformation. The planet's story is not one of fragility, but of endurance. And in that endurance we find our own reflection, fragile yet persistent, temporary yet eternal. The pale blue dot we inhabit is not simply a world that once survived the Paleozoic. It is the child of that age, still carrying its heartbeat beneath the crust and within the sky. When we look to the stars, wondering where we came from, we are really looking inward, into the layers of time that made us. The continuum remains unbroken, the memory undimmed. The Paleozoic never ended. It continues within every wave, every breath, every living thing that still dares to exist. When continents moved and oceans breathed, the planet in motion. Throughout the Paleozoic, the Earth was never still. Beneath calm seas and thriving forests, titanic forces sculpted the surface in an endless dance of collision and creation. Continents drifted like slow-moving rafts, carried by the restless tides of molten rock beneath. Mountains rose, oceans opened and closed, and coastlines shifted with a rhythm too vast for any creature to perceive. The planet was not a stage upon which life acted. It was a living participant in the drama of existence, breathing and changing with every age of the history of the Earth. In the Cambrian and Ordovician, the continents were scattered like islands adrift, surrounded by warm, shallow seas. These environments became cradles of diversity, where evolution found space to experiment freely. By the Silurian, tectonic forces had begun to pull land masses together, birthing new ranges and shallow inland seas. Each movement altered climate, temperature, and ocean currents, reshaping not only the face of the world, but the destiny of every living thing upon it. By the Devonian, this continental drift reached a crescendo. Vast collisions folded the crust, raising mountain chains that would one day become the Appalachians and the Caledonides. As the continents merged, rivers poured sediments into expanding basins, forming deltas that would nourish entire ecosystems. The Earth's geology became a mirror of its biology, both systems evolving together, each shaping and feeding the other in a cycle of endless reciprocity. The Carboniferous brought calm after the storm. The continents settled for a time, and the stability allowed forests to flourish. Swamps grew in lowlands between mountain ridges, storing carbon and exhaling oxygen into the atmosphere. But even in this tranquility, the Earth was preparing for another transformation. Deep within its crust, pressure and heat built steadily, the precursor to the monumental unification of land that would define the Permian. When the Permian dawned, the continents had converged into Pangaea, the greatest supercontinent the planet had ever known. Its formation reshaped everything. The interior was a furnace of dry heat, while vast coastal regions experienced alternating floods and droughts. Ocean currents changed, climates fractured, and ecosystems evolved to face both feast and famine. The unification of Pangaea was the Earth's grand experiment in global connection, but also a warning of the fragility that comes with interdependence. The Panthalassic Ocean surrounded this colossal landmass like a mirror of infinity. Beneath its waves, ancient currents carried nutrients and heat around the globe, maintaining a balance that was as delicate as it was essential. When volcanic eruptions or climatic shifts disturbed this system, the consequences rippled through every level of life. Ocean chemistry, atmospheric gases, and continental weather patterns were all bound together. One breath, one pulse, one planet. Even the process of mountain building, or orogeny, was a sculptor of destiny. As the crust rose, it altered wind patterns and rainfall, creating new environments for adaptation. The story of evolution cannot be told without the story of the rocks beneath it. Every species that ever lived was shaped by the continents it walked upon and the oceans that cradled it. The Earth itself was the first artist, using pressure and fire as its tools. By the end of the Paleozoic, the planet had transformed from a scattered archipelago into a single, interconnected world. But unity carries risk. When change comes, it touches everything. The same tectonic harmony that had built Pangaea would later conspire in its undoing. The supercontinent would crack, the seas would shift, and the stage would be reset for new chapters of creation. The Earth was never static, never safe, but always alive, moving, breathing, and remembering. The breath of time. How the Paleozoic forged Earth's atmosphere and climate. Long before humanity learned to measure air or trace the carbon in its breath, the Earth had already spent hundreds of millions of years crafting the delicate balance of gases that sustains life. The atmosphere we know today, the sky we take for granted, is the product of the Paleozoic's long and patient labor. It was an age when the planet learned to breathe, when the chemistry of the air was rewritten by forests, oceans, and volcanoes, and when the rhythm of climate began to follow the pulse of life itself. In the early Paleozoic, oxygen was scarce, and carbon dioxide filled the air. Volcanic eruptions painted the skies in haze, their gases feeding the first global greenhouse effect. The warmth of this atmosphere kept the oceans liquid and alive, but it also constrained complexity. When photosynthetic organisms spread through the Cambrian seas, they began to exhale oxygen, setting into motion one of the most profound transformations in the history of the Earth, the birth of breathable air. As plants colonized the land in the Silurian and Devonian, the planet's respiration intensified. Vast stretches of greenery absorbed carbon dioxide and released oxygen in quantities the atmosphere had never known. For the first time, fires became possible, a sign that oxygen had risen beyond 13%. The skies deepened to a familiar blue, and the weather patterns began to stabilize around a living balance. Every leaf, every wave, every gust of wind participated in a grand experiment that would shape the destiny of life. By the Carboniferous, the air itself had changed so dramatically that it bordered on the surreal. Oxygen levels soared above 30%, turning the atmosphere into an engine of growth. Insects grew to impossible sizes, amphibians flourished, and forests expanded endlessly under dense, moisture-laden clouds. The Earth's climate became both generous and volatile, warm, wet, and rich with life. Yet with abundance came instability, for nature allows no excess without consequence. When the coal forests fell and decomposed, their carbon was buried deep beneath sediments, locking away vast amounts of greenhouse gas. This quiet act of sequestration cooled the planet, triggering glaciations that swept across the southern continents. The Earth's breath slowed, temperatures dropped, ice formed in regions that had once been tropical. The Carboniferous balance between oxygen and carbon, life and decay, tipped again, reminding the planet of its fragility. Then came the Permian, when the Earth exhaled fire. Volcanic eruptions of unimaginable scale poured carbon dioxide and sulfur into the air. Global temperatures surged, acid rain scoured the land, and the oceans turned stagnant and anoxic. The atmosphere, once a cradle of life, became a weapon of extinction. The balance that had taken 300 million years to build collapsed in mere moments of geological time. The breath of the planet grew ragged and weak, its harmony broken. Yet even in collapse, the Earth was learning. The atmosphere evolved not just through destruction, but through adaptation. The feedback loops between volcanism, weathering, and life refined the climate system that persists today. The very stability that allows humanity to exist was forged through cycles of chaos, ice and fire, oxygen and ash. Every storm, every breeze, every drop of rain carries a memory of those ancient corrections. By the end of the Paleozoic, the planet had found its rhythm, one that would endure into the Mesozoic and beyond. The atmosphere had become a living entity, intertwined with the oceans and the biosphere, a self-regulating web of chemistry and motion. The Earth had learned to breathe, deeply, rhythmically, eternally. And within that breath lay the promise that, no matter how many times life faltered, the sky itself would always remember how to begin again. The language of fossils, memory preserved in stone. Long before words, the Earth wrote its story in stone. Every mountain, every canyon, every grain of sediment carries a line of that script, the language of fossils. These are not mere relics of the past. They are letters in the planet's autobiography, written in the quiet patience of pressure and time. The Paleozoic, with its vast record of life's first great experiments, is the opening chapter of that eternal text, a record of how existence learned to record itself. In the Cambrian layers, the earliest fossils are faint impressions, soft-bodied creatures preserved in fine silt, their delicate outlines barely clinging to the rock. Yet those traces speak louder than any monument. They reveal the first surge of diversity, the moment when life found form and dared to leave its mark. Each trilobite shell, each worm trail, each coral fragment is a word from an age when memory itself was being invented by the Earth. As the Paleozoic unfolded, fossilization became the planet's archive of evolution. In the Ordovician and Silurian rocks, coral reefs appear like frozen cathedrals built from the skeletons of long-dead colonies. Their structures reveal not just what lived, but how. The chemistry of the water, the warmth of the climate, the rhythms of ancient tides. In these stony pages, paleontologists read the pulse of lost oceans and the migrations of vanished continents. The rocks remember what the surface forgets. The Devonian brought fossils of fish unlike anything seen before. Armored giants, finned pioneers, and the transitional forms that would one day give rise to amphibians. In their bones, the record of transformation is preserved. Lungs evolving from swim bladders, fins stretching into limbs. These fossils are not only anatomy, they are evidence of decision, of movement toward land, of life testing the boundaries of its own nature. The rock holds not just bodies, but ambition. Then came the Carboniferous, where forests left behind entire worlds beneath the soil. Fossilized ferns, bark impressions, and seams of coal record an age when greenery ruled the earth. Within those black layers lies a paradox, death that became the foundation of future energy. Humanity's industrial revolutions burned the ghosts of that time, releasing ancient sunlight trapped in the veins of stone. Every spark of electricity, every flame, is the voice of a Paleozoic forest remembering. Even extinction has its fossils. The Permian layers are full of abrupt endings, shells truncated mid-lineage, coral beds replaced by barren strata, and sudden absences where diversity once bloomed. In the rocks, the record of silence is as powerful as the record of abundance. These gaps are the punctuation marks of time, the pauses between chapters when life faltered and the planet rewrote the script. The stone remembers everything, including loss. For scientists, fossils are not simply curiosities, but instruments of translation. They allow us to speak the language of epochs, to hear through the static of eons. Each discovery adds a syllable to the vocabulary of deep time, teaching humanity humility in the face of scale. Through fossils, we realize that our history is not 6,000 years old, nor even 6 million, but stretches back across nearly 500 million years of struggle, mutation, and persistence. And yet, even with all we've uncovered, the text remains unfinished. The majority of Earth's story still lies buried, waiting for hands and minds willing to read it. Every fossil unearthed is both an answer and a question, an invitation to continue decoding the dialogue between rock and life. The Paleozoic taught the Earth to remember, and in doing so, it taught us to listen. For in every stone lies a whisper of what we once were and what we still are becoming. The Architects of Survival, How Life Conquered Change. Every era of the Paleozoic tested the limits of endurance. It was an age not only of creation, but of confrontation, between stability and chaos, between fragility and persistence. The organisms that thrived were not the strongest, nor the most intelligent, but the most adaptable. They were the architects of survival, building the framework of evolution through trial, error, and transformation. Their legacy endures in every heartbeat that still echoes across the history of the Earth. The Cambrian pioneers began the experiment. In their soft, uncertain bodies, life discovered structure, shells, spines, and armor that provided both protection and possibility. Each adaptation was a gamble against extinction, and each failure a note in nature's growing lexicon. Trilobites refined sight, mollusks learned defense, and predators honed precision. Survival became an art, shaped by time and chance, until the planet itself pulsed with evolutionary creativity. Then came the Ordovician seas, where diversification became destiny. Organisms expanded into new ecological roles, filling every available niche with purpose. Coral reefs rose like living fortresses, and cephalopods evolved intelligence and control. But when ice returned and the world froze, those who endured were not those who fought the cold, but those who could hide, adapt, or change. The first great extinction became the planet's first great teacher, proving that survival is never about resistance but about flexibility. In the Silurian, adaptation found a new frontier. Land, plants, arthropods, and early vertebrates became explorers of a new dimension. They developed roots to drink from soil, waxy coatings to preserve water, and limbs to move where fins had failed. The courage to step from the sea was more than evolution. It was defiance. It was life's declaration that boundaries exist only to be crossed. Every tree that stands today, every creature that walks, carries that act of rebellion within its blood. The Devonian tested innovation with violence. The seas swarmed with predators, the land grew forests that cooled the planet, and extinction struck again. Yet, from the chaos emerged new solutions: lungs, limbs, and resilience. Amphibians ventured into rivers, insects filled the skies, and plants reshaped the carbon balance of the air. Each adaptation rewrote the rules of survival, proving that catastrophe and creativity are siblings in nature's endless dialogue. By the Carboniferous, life had learned to build empires. Lush forests created their own climates, amphibians ruled swamps of infinite green. But evolution, ever restless, produced the reptile, the first true master of independence. Shelled eggs freed them from water's grasp, allowing life to colonize deserts and plains. The architects of survival had discovered autonomy, and in that moment, the blueprint for all terrestrial life was complete. The Permian then arrived as the ultimate trial. Droughts, heat, and fire ravaged Pangaea, and yet some species endured through remarkable adaptation, thicker skins, efficient lungs, and new metabolic strategies. When the Great Dying came, almost all perished, but not all. Those who remained, small, obscure, forgotten, carried within them the resilience of everything that had come before. The future belonged to them, and through them, to us. From the smallest trilobite to the towering tree fern, every creature of the Paleozoic was a participant in this grand experiment of persistence. Together, they built the architecture of life, layer upon layer of trial and triumph. The architects of survival did not merely adapt to the Earth, they taught the Earth how to sustain them. And through that exchange, the planet became what it is today, a living, breathing monument to endurance, memory, and change. Fire, stone, and time, the planet's eternal rebirth. Across the vast expanse of geological time, the Earth has burned, frozen, fractured, and healed, yet it has never ceased to move. Fire, stone, and time are the trinity of its transformation, the elements through which existence is both destroyed and renewed. The Paleozoic was not a single story, but the first act in an eternal cycle, the template of how a living planet evolves, recovers, and remembers. Within its fiery heart and silent layers, the blueprint of rebirth was written forever into the history of the Earth. The fires that once scorched the Permian plains were not endings, but beginnings. Volcanic eruptions darkened the sky, Yet they also fertilize the soil for future forests. Lava hardened into new crust, giving rise to the continents that would cradle the next waves of life. In destruction, the Earth replenished itself. The same heat that took life away was the energy that rebuilt it, a paradox that defines the planet's rhythm from its birth to this very day. Stone, too, is not a symbol of permanence, but of change. Every mountain that rises will one day crumble. Every ocean floor will one day lift toward the sky. The rocks of the Paleozoic, unfolded, compressed, and metamorphosed, still whisper of those upheavals. They hold within them the weight of gravity and the fingerprints of ancient seas. Stone is the Earth's memory made solid, a testament that even the hardest forms yield to time's quiet persistence. Time, the final architect, does not destroy. It transforms. It does not rush. It reshapes. Over hundreds of millions of years, time allowed single-celled organisms to become complex ecosystems, silence to become song, and chaos to become balance. It erased empires of coral and replaced them with forests of fern, then exchanged those for deserts of sand. Time is not cruel, only patient, teaching that creation and loss are both necessary chapters in the same cosmic manuscript. Through fire, the Earth renews. Through stone, it remembers. Through time, it evolves. The Paleozoic revealed this truth more clearly than any other era. It showed that no extinction is final, no catastrophe absolute. When life seems broken beyond repair, the planet responds not with despair, but with invention. Every collapse becomes the foundation for something greater. Every silence a pause before a new symphony of existence begins. Even today, those same forces continue to sculpt our world. Volcanoes breathe new land into the ocean. Erosion carves mountains into valleys. And deep within the mantle, molten currents shape continents for futures yet unseen. We walk upon a planet in constant renewal, a world that, like us, endures by changing. The landscapes we call ancient are merely moments in its ongoing metamorphosis, a single heartbeat in its 4.5 billion-year life. The Paleozoic ended in ruin, but ruin was not its legacy. Regeneration was. From the ashes of the great dying came the seeds of the Mesozoic, from which the dinosaurs would rise, the forests would spread again, and the cycle of life would find new form. The Earth, scarred yet unbroken, had proven itself indestructible in spirit. Its heart of fire still beat, its oceans still breathed, and time itself still carried the promise of rebirth. Fire cleanses, stone endures, and time forgives. This triad defines not just geology, but existence. Everything that has ever lived, every species, every civilization, will pass through the same crucible. Yet the pattern remains, from destruction, creation, from silence, song, from ending, beginning. The Earth is not a monument of stillness, but a living cathedral of change, eternal, restless, and magnificent. The human reflection. We are the children of ancient Earth. When we look at the world around us, the mountains, the seas, the wind tracing through forests, we are not gazing at something separate from ourselves. We are witnessing our own origin. Every human breath, every heartbeat, every thought is a continuation of a process that began in the Paleozoic. We are not apart from the Earth story. We are its most recent verse. The atoms in our bones, the minerals in our blood, the oxygen in our lungs, all are gifts from that ancient age when the planet first learned what it meant to live. The iron that courses through our veins was forged in volcanic hearts and carried through Paleozoic seas. The calcium that builds our skeletons once belonged to trilobites, corals, and shellfish, turned to dust, then reborn as us. The carbon that fuels our cells came from the forests of the Carboniferous, buried beneath pressure and time, then freed once more to ignite life. Humanity is not an observer of deep time. We are its embodiment, its echo made conscious. Our existence mirrors the same principles that guided the Paleozoic Earth. We adapt, we struggle, we rebuild. Civilizations rise like continents, collide like tectonic plates, and fall back into dust, only to be reimagined anew. We are driven by the same forces that shaped life's first experiments: curiosity, survival, transformation. In our cities, our technology, even our art, the pulse of geological creativity still beats. We build as the planet once built, through trial, tension, and time. The lessons of that age are written in our very nature. The Earth teaches us that stability is an illusion, and that resilience is born of change. Just as the trilobite gave way to the amphibian, and the amphibian to the reptile, so too must humanity evolve, not only biologically, but consciously. To endure is not to dominate, but to adapt. To survive is not to resist transformation, but to flow with it. The history of the Earth is not a warning. It is an invitation to continue. When we burn coal or breathe air, we participate in the same cycles that have turned for hundreds of millions of years. The difference is awareness, the ability to know that we are part of the pattern, not outside it. The fossil fuels that drive our machines are the breath of forests that died long before our kind existed. The oxygen that fills our lungs is the exhalation of life that never saw a sky like ours. We live on the generosity of ghosts, and our future depends on whether we honor their legacy or exhaust it. The Paleozoic also reminds us of humility. The Earth has endured cataclysms beyond comprehension and recovered each time. Our species, brilliant yet fragile, is but a flicker in that timeline. We are ancient and temporary all at once, descendants of the first eukaryotic cells, standing on continents that once lay beneath warm seas. To recognize that lineage is not to feel small, but to feel connected. To understand that our story is written into the crust, the clouds, and the cosmos itself. In the mirror of the Earth's history, humanity sees both its fragility and its strength. We are capable of destruction, but also of regeneration. We have inherited the planet's creative impulse. The same energy that built trilobites and forests now builds ideas and compassion. Our choices, like tectonic shifts, will shape what comes next. Whether we bring another extinction or another renaissance depends on how deeply we remember that we are made of ancient soil and starlight. The Earth does not belong to us. We belong to it. We are its memory given voice, its consciousness made flesh. To live wisely is to remember the depth of our ancestry, that we are children of oceans older than the moon, heirs of forests that turned to stone, and the latest expression of a world that never stopped reinventing itself. The Paleozoic may be gone, but its essence breathes through every human alive today, through every inhale, every heartbeat, every dream that reaches for tomorrow. The last echo of the Paleozoic, time's gift to the future. Even after hundreds of millions of years, the Paleozoic has never truly ended. Its echoes still ripple through the planet's oceans, flow through our atmosphere, and resonate within the DNA of every living being. Time may have buried its continents, silenced its forests, and scattered its fossils across stone, yet its legacy endures, a quiet hum beneath the surface of everything that breathes. The Paleozoic was not only the foundation of life, it was the planet's first whisper of eternity, a reminder that what begins in chaos can end in creation. The last pulse of that age, the Great Dying, was both an ending and a beginning. It showed that even the most perfect equilibrium can collapse, and yet out of ruin something greater can rise. That is time's greatest gift, transformation. The Paleozoic did not fail. It evolved. Its final silence was not death, but transition, the bridge between the world that was and the world that would be. The Mesozoic dawn that followed was not separate from it, but born of its ashes, carrying forward its lessons of endurance, adaptation, and renewal. The rocks of that ancient era still breathe their stories through us. The oxygen we inhale, the coal we burn, the limestone beneath our feet, all are relics of those primeval epochs. The warmth of our homes, the spark of our machines, even the power of our words are drawn from the energy of the Paleozoic Earth. Humanity lives on the inheritance of time, the sunlight trapped by forgotten forests, the minerals forged in vanished oceans, the breath of creatures long turned to dust. To live today is to stand upon the shoulders of eons, but this gift carries responsibility. The same geological forces that once destroyed worlds now rest in our hands. We shape the atmosphere, redirect rivers, and alter climates with the same magnitude, once wielded by volcanoes and tectonic shifts. The Earth no longer changes alone, it changes with us. The lesson of the Paleozoic is clear. Balance is not given, it is earned. To forget that lesson is to invite the same silence that once fell over Pangaea. And yet hope endures. The Earth's resilience is written into every atom of its being. It has faced extinction, fire, ice, and darkness, and every time it has found a way to begin again. So long as life persists, the song of the Paleozoic continues. It plays in coral reefs that echo their ancient ancestors, in rainforests that recycle the wisdom of the Carboniferous, in the pulse of humanity that still carries the rhythm of those first beating hearts in Cambrian seas. Time, in its mercy, never truly erases. It transforms memory into matter, loss into foundation, and ending into evolution. The fossils buried in stone are not merely remnants, they are the planet's memory banks, storing not sorrow, but possibility. When we study them, when we listen, we are not just learning about the past, we are touching the continuity of existence itself. The Paleozoic's last echo reminds us that nothing vanishes completely, everything becomes something new. And so, the story circles back to us. The Earth has gifted us time, the rarest element in the cosmos. What we do with it will become the next layer in its unending chronicle. One day, long after we are gone, the stones will remember our age, our triumphs, our mistakes, our transformations. The fossils of tomorrow are already forming beneath our feet. Whether they tell a story of collapse or renewal depends on how well we remember the first great lesson written by the Paleozoic world, that survival is not about enduring time, but evolving with it. The last echo of that era still hums beneath the surface, waiting for those who listen. The Earth has never stopped creating, never stopped forgiving, never stopped beginning again. The Paleozoic gave it that gift, the courage to rise after ruin, the faith to continue after silence. And in that eternal rhythm we find our truest inheritance, not the stones or the fossils, but the will to begin again, no matter how many times the fire falls. The planet that never forgets. The Paleozoic began with silence and ended in fire. Between those two extremes, the Earth learned what it meant to live, to grow, to suffer, and to endure. Every coral reef, every fern, every creature that crawled from the sea left an imprint on the world that followed. The continents may have shifted, the oceans may have changed their names, but the legacy of that age still pulses beneath our feet. The Paleozoic was not merely an era in the history of the Earth, it was the foundation of everything that breathes. When we look back across those 300 million years, we see not just extinction, but resilience. The Great Dying did not erase life, it refined it. Out of ash came adaptation, and from the ruins of Pangaea, the blueprint for the future. It is a truth older than humanity. Destruction and creation are never separate. They are threads of the same eternal pattern. The Earth's story is not a straight line. It is a spiral, circling endlessly through transformation. We owe our existence to that pattern. The air we breathe was crafted by Paleozoic forests. The land we walk upon was built from sediments of vanished seas. Even the energy that powers our civilization was born from the sunlight, those ancient trees once captured. We live on the inheritance of a planet that never stopped renewing itself, a planet that remembers how to begin again after every fall. Yet, as we shape the world today, we face the same truth that shaped it then. Balance is fragile. The forces that once drove mass extinctions, climate shifts, volcanic eruptions, chemical imbalance, now echo through our own actions. The Paleozoic does not simply belong to the past. It speaks to the present, reminding us that survival is not about control, but harmony. We are not outside the story of the Earth. We are its latest chapter still being written. So as we close the book on the Paleozoic, remember this: time is both merciless and merciful. It erases and it restores. The fossils beneath the ground are not symbols of death, but of persistence, proof that life, once awakened, refuses to vanish. The same fire that once consumed the world still burns within every living thing. It is the will to continue, to evolve, to endure. The history of life on Earth, wrote paleontologist Stephen Jay Gould, is a story of contingency and survival, a million possibilities most never realized, and a few that led to us. We are one of those possibilities, the living continuation of a planet that learned to dream through extinction. This has been the story of the Paleozoic Era, the age when the Earth became alive. You are watching Chronicles of Earth. If you felt the power of time in these words, subscribe to the channel, activate the bell, and join us as we continue this journey, where every rock, every fossil, every heartbeat tells the story of the world that remembers.